Hello and welcome. My name is Ethan, and today I'll be going over my presentation for Track A on the Google Data Analytics Certificate titled How Do Cyclistic Members and Casuals Differ? This case study leverages real-world data in a hypothetical situation in order to test some of the skills that I've learned throughout said certificate. Throughout this presentation, I'll be going through the company background, the business challenge, learning objectives, the data, my analysis, my conclusion, and recommendations. Well, to begin with, who are Cyclistic? Formed in 2016, Cyclistic is a fictional bike share company based on the real bike share company in Chicago, Divvy. Cyclistic has formed a network of over 5,800 bikes across 690 stations in Chicago. They've owed a large part of their success about the flexibility on their ride passes, the single ride pass, the day pass, and annual membership. Cyclistic has categorized its riders into two groups: members who purchase the annual membership and casuals who purchase either the single ride pass or the day passes. So what problems are Cyclistic facing? Cyclistic's financial analysts have concluded that annual members are far more profitable than casual riders. Moreno, the director of marketing, believes that instead of targeting new customers, we should focus instead on digital marketing strategies that will convert casuals into members. Therefore, our goal is to create metrics using the last 12 months worth of historical data that will indicate differences between casual and member rider behavior, which will help us improve the conversion of casuals to members in next year's digital marketing strategies. By the end of this presentation, I'll have explained to you the metrics that we can use to identify behavioral differences between casuals and members, the differences in the needs between casuals and members who use our cyclistic services, as well as how the casual needs can inform new digital marketing strategies aimed at improving user type conversion. With our objectives confirmed, how about we take a look at the data? Cyclistic's historical data used in this case study is publicly available data from the real Chicago bike share company, Divvy, and the link to this data as well as its license are available in the description below. The past 12 months worth of historical data is coming from May 2024 to April 2025. And the data is Divvy's first-party data. It has trustworthy accuracy, completeness, and objectivity, all vetted by Google, proven fit for use. The 12 months of data, when merged together, contained over 5.7 million rows of data across 13 columns. Now, while the data has a high level of integrity, there are some limitations to the data. For starters, due to the anonymization of data, there's no personally identifiable information in it. So while this is a good thing for our customers, it also means that I can't infer whether someone is a local within the service area or if they purchased multiple ride passes. Secondly, there were several instances of illogical timestamp data where the ride end time was actually archived before the start time, which is just nonsensical. This would be where, in a real situation, I'd ask the data owners why this is happening and perhaps how we could remedy it. But for the cases of this fictional Capstone project, I work alone, and I just chose to remove those records, which concluded about 2% of the data. Due to the low stakes of this case study, we'll still be able to gain accurate results, but it's something to keep in mind. The third issue is that there were several null values found in the bike share station information, although this had no impact on my findings, as we'll see in the next slide. Finally, the fourth issue was that the user type data was binary, meaning that there was only members and casuals, which is not the best and most precise thing because casuals are actually two types of user. They are either single ride passes or day passes. It would have been really useful to have more precise measurement for the user types because it could have indicated which choice, whether single ride pass or day pass, was more popular, when, for what reason. We could have inferred something from that, but we just can't. Despite these limitations in the data, I've been able to work around these by cleaning and transforming the data in a way that makes it still useful for accurate information. Originally, there were 13 columns, including things such as ride ID, the rideable type of bike, the started and ended at times, geographical information regarding the bike share station locations, as well as the user type information. When transforming the data, I decided to continue working with rideable type, as well as member casual, which I have renamed to user type for simplicity's sake. Member casual, or user type as I'm now calling it, is a key independent variable for proving any hypotheses around a business objective, so keeping it was a given. Rideable type is a dependent variable, and it can be useful for discerning the choice between casuals and members and inferring differences between them, therefore. using these started at and ended at columns, I used the date time data to create some new columns. We've got day of the week, month, and hour of the day. These will let me measure the daily, the weekly, and the annual behaviors of casuals and members. And finally, I created a trip duration column called duration minutes using the timestamp data, which will help me analyze how long a ride lasted for and potentially the purposes of the ride. I chose not to use any of the geographical data from the original 13 columns because while there are potential uses for it, they are redundant or just outright flawed. For instance, you could use the started at and ended at positions to calculate a travel distance, but the problem with doing that is that these two positions alone don't define a travel route. You could ride in circles or around the world and end the same place. It's just not accurate as a travel distance. Having an already accurate trip duration column, trip distance in this inaccurate way would also be made redundant because I already know what the longevity of each ride is. Another potential use for the geographical data of a bike share station is knowing which station was the most popular by our riders. Now, considering the context of our situation here, this is a bike share company, and each bike share station should have a uniform design with equal features. So therefore, there'd be no reason for a rider to pick one bike station over the other apart from proximity convenience. So knowing the most popular stations from our riders, it won't indicate any choice by the riders and therefore why they ride bikes. It would only determine where our audience is most concentrated in Chicago. Now, while that is useful in some situations, such as putting your focuses on marketing in said locations which are more popular, again, context indicates that as a bike share company, we don't care about geographical marketing. We care about digital marketing. We use applications. We have direct contact. There's no reason to locally advertise one station when we can just post to every single rider in the network. So geographical data was not useful in my case study. With the columns to be used chosen, I cleaned the data by removing white spaces, typos, duplicates, nulls, erroneous values, as well as outliers. However, while removing the outliers, I noticed something interesting about the data distribution. This blue line you're looking at is actually a data distribution for every single data point in duration minutes, the column I was checking for outliers. The horizontal lines towards the bottom of this data distribution are actually a box plot that represent the majority of our data. And as you can see, the majority of our data is very short compared to the rest of the ride duration data, the maximum being 34 minutes. What this told me about the data is that while the majority of our data of trip duration is between 1 and 34 minutes, a very significant amount of our data is actually beyond that, therefore making the data heavily tailed. This means that the mean and standard deviation are going to be very skewed and a lot higher than the median, therefore making the median a better measurement for central tendency. And so I'm left with a choice. Do I remove all of the data beyond 34 minutes, create a more normalized distribution that will fix the mean and standard deviation at the cost of some data? Or do I move forward accepting the heavy tail, knowing that those statistics are going to be skewed? As for why the data is heavily tailed, we need to remember the context of our data. You see, bikes have a lot of uses for a lot of different reasons. You just think about a couple, you can think about going to work, going to school, regular deliveries, exercise, tourism, recreation, and I'm sure the list goes on beyond that. Out of these activities, you'd expect that daily activities such as going to work or going to school or regular deliveries would be the predominant source of our data. And I believe it is this predominant source, these daily and regular rides that happen all the time, are creating this small average towards the bottom 1 to 34 minutes, whereas the rest of the activities such as exercise, recreation, tourism, yada yada, all of that is creating longer ride trip durations and therefore this heavy tail of data. What this means about our data is that while we have a normalized distribution between 1 and 34 minutes, there is still a lot of valid and valuable data beyond 34 minutes of trip duration indicative of longer duration activities, which we can use to infer why people use our bikes. Considering that the business objective for the study is to analyze the differences in rider behavior between casuals and members, I saw very little reason to marginalize these rider types from our study. Therefore, I'm keeping all of the ride duration data beyond 34 minutes. With the data cleaned, I then analyzed the data using SQL and Tableau. To start us off, I've got a pie chart that shows the distribution of rides made broken down by user type. And as you can see from the percentages, casuals make up over a third of our audience. Now, while casuals remain the minority of our audience, this is a very significant amount of income that isn't as profitable, secure, or consistent as our membership annual income. It's also worth noting the brand loyalty and retention that's being missed in this 36%. On top of that, digital marketing efforts are far cheaper to members than casuals due to having a direct point of contact. In summary, the data definitely backs up the point that we need to improve the conversion of casuals to members. Continuing our overview of the data, I'd like to show you a couple of summary statistics. Here we have a table showing the number of rides, the average, standard deviation, lower quartile, median, and upper quartile of trip duration minutes, broken down by user type, casual, and member. The average and median both are a measure of central tendency, indicating how long a ride typically lasts for, while the standard deviation and both quartiles are measures of spread, which indicate how much the duration of a ride tends to vary. As mentioned earlier, the data is heavily tailed, meaning that the average as well as the standard deviation are going to be skewed, making median and the quartiles better measures of central tendency and spread respectively. However, I've still included them in this table because the average and deviation will still provide corroborating evidence for the relationship between casual and membership rides. Both measures of central tendency, the average and the median, show that casuals have a higher ride time on average than our members. Our measures of central spread, the quartiles as well as the standard deviation, both show that the casuals have a greater variety of ride times than members. This implies that members have a much more uniform use for bikes than casuals, who have longer and more varied ride times. As for exactly what these bikes are being used for, we're going to have to take a deeper look into the data. We'll begin by looking at the daily habits of our riders. This is a group bar chart showing the number of rides for each user type broken down by hour of the day. And once again, the casual members are colored lime green, while our members are colored in teal. When we look at the casual data, we can see that it gradually increases towards the evening, peaking at around 5 p.m. before gradually decreasing as night approaches. By examining our members' data, we can see two spikes are around 7 to 9 a.m. as well as 4 to 6 p.m. This is likely due to regular work schedules and school commutes, as this coincides with the typical 9 to 5 workday. From this, we can already deduce some of the reasons why people may choose between casual options and member options. Riders who want to use bikes for daily commutes typically will gravitate towards our annual membership, as they will likely save money in the long run instead of purchasing casual options throughout the year biking every day. However, the lack of peaks at 9 to 5 for casual members show that they are a completely different audience than daily commuters, and that the annual membership simply doesn't meet their needs. Perhaps they like riding at different times of the week or times of the year. The next graphs are going to answer this theory. To analyze the weekly habits of our riders, I've got a group bar chart here showing the number of rides for each user type broken down by day of the week. We can see that members have their peaks during the weekdays and their lowest number of rides during the weekends, whereas casuals on the other hand are the polar opposite. They have their lowest number of rides during the weekdays and their highest during the weekends. Again, there are some valuable insights we can gain from examining this data. The evidence corroborates with our earlier theory that members are daily commuters using bikes primarily for work or for school, as these activities happen between Monday and Friday. This also identifies a habit of our casual audience. They love riding during the weekends, and it implies that a large portion of this casual audience enjoy riding recreationally on the weekends, when work isn't a factor. Now that we know why members and casuals ride bikes, it'll be interesting to see if seasonality has an impact. To analyze the annual habits of our riders, I've got a group bar chart here showing the number of rides for each user type broken down by month of the year. We can see that in the warmer months, both casuals and members have an increase in the number of rides, whereas in the colder months, they have their lowest. Therefore, we can confirm a significant seasonality for both casuals and member riders. Both members and casuals don't like riding during cold months. We can also see a higher seasonality in our casuals than our members. The members, while affected by seasonality, don't have their number of rides drop nearly as much or significantly as the casuals. This is a nod to the theory that members are daily commuters using their bikes for work, who can't always just choose not to go in that day, whereas casuals who are riding primarily for recreational reasons can choose not to ride during cold months. This graph also helps us identify another factor about our casual audience. A large part of them are likely tourists coming to Chicago during the summer, as implied by their peaks during June to September. I feel as though we have enough information to draw conclusions on, but there is one more avenue I'd like to take you through. This is a group bar chart showing the number of rides for each user type broken down by rideable bike type. As you can see, we've got electric bike, classic bike, and the electric scooter. Since the electric scooter is the easiest ride option between the two bikes, it can be used as an indicator to see how casuals and members value the ease of transport. When analyzing the data, it's quite obvious the electric scooter falls short as our least popular ride option. However, when I was analyzing the data for why this is the case, I found out that the electric scooter only had existing records in September. Now, again, in a real situation, I'd have to ask the data owner why this is the case, but since I'm alone in this project, I'll sadly never know. On the bright side, however, I could filter the data to only show rides made in September. This provides a much more balanced view as to which bike was the most popular. However, electric scooters still fall short, sadly, compared to our pedal options. It should be noted though that despite the electric scooter being such a rarity in our dataset, it has revealed a very interesting pattern. You see, when we look at all three groups of rideable type, casuals fall short compared to members, apart from the electric scooter. Remembering that the members are the primary source of our data and that casuals make only a third of it, the fact that casuals outweigh members on the electric scooter in particular is very interesting. So in summary, this graph has told us that both user types enjoy pedal options over the electric scooter, showing that they have an appreciation for the health benefits found in cycling. Despite casual riders being half of the audience that our members are, they've managed to outweigh the electric scooter numbers, showing just how much more they value ease of transport than our members. This corroborates with our earlier theory that our casual target audience are largely made out of tourists. This is likely due to the fact that tourists typically don't know the public transport routes, nor can they use their own transportation from back home. Thus, they rely on the next easiest thing, an electric scooter. These allow tourists to go wherever they want with flexibility on the go. With the data analyzed, I'm now ready to present my conclusions. In summary, we found out that casuals make up over a third of our market, confirming the importance of increasing our conversion from casuals to members. Members are riders who typically use bikes for daily commutes during the weekdays, such as for work or for school. Casuals typically have longer bike rides and a greater variation in their use for bikes than members. For instance, casuals prefer to ride during the weekends or during the summer for recreation. On top of that, a significant portion of our casual audience are tourists. Both rider user types enjoy riding during the warmer months of the year, and both user types appreciate the health benefits of cycling regularly. And finally, while we have an annual membership that does well at tackling the audience of daily commuters, there is a large and untapped audience of casual riders we're just not meeting the needs of. Our goal is to convert casuals into members. We need to find a way that we can bridge to that untapped audience without alienating our existing audience of daily commuters. Therefore, instead of advertising our current annual membership to casuals or altering the existing one, we should develop new membership options that do meet the needs of a casual audience. And so, I'm bringing us to my top 3 recommendations. A new semi-annual membership. This would be an annual subscription similar to our existing membership, only that it would provide the customer with the choice of which 6 months of the year the pass is valid on, improving flexibility, a staple to the success of the Cyclistic brand. Naturally, the semi-annual membership will be cheaper than our annual membership, and will also be cheaper than paying for casual options throughout 6 months. This will incentivize riders to make that upfront payment and subscription with us, while also making a saving biking when they want to. My second proposal is a new weekend membership. This will give bike access to our riders during our casual audience's favorite times of the week to ride, Saturday and Sunday. I recommend a monthly subscription for the weekend pass, as this will grant the same cash flow security benefits as our regular subscription. However, in the case that this option seems to fall behind, we can change it to a weekly rolling subscription instead, because casuals hate cold months, which is half of the year, mind you. Again, a monthly subscription might not meet their needs if they hate cold months, so a weekly rolling subscription could be better. However, we need more data to weigh up the value of whether we should have the monthly subscription, which has greater cash flow benefits and retention, but lower flexibility, or have the weekly version where flexibility is higher, However, the retention and security of our cash flow is lower. My third proposal is new summer advertising. The summer advertising will show our new membership options leading up to the summer in good time for our casuals to act on. The summer advertising will keep a focus on what our casuals love about riding bikes: the summers of Chicago, tourism, the ease of transport, and the health benefits of riding on a weekly basis. Combining this advertising with our new membership options will not only draw in more of the casual audience, but show them that we have exactly the membership that they're looking for. In summary, by acting on these three initiatives, we can meet the needs of our casual audience, bridging them towards becoming members. We'll show that we have exactly the type of membership for when they want to ride, when they have time to ride, as well as when it's warm. This is the part of the presentation where I'd open up for questions from the audience, but since this is a video, I'm relying on the comment section for this one. If you have any questions about what I've done or anything I've talked about in this video, please just comment it below and I'll reply whenever I have time. Furthermore, if you want to see exactly how I conducted this case study, I have an article on LinkedIn that documents the entire process. It shows my justification for decisions I made, the software I used, the coding that I did, how I worked around issues, as well as my considerations when visualizing the data. I also have an interactive dashboard on Tableau, where you can go and play with the visualizations yourself. The links to both my article as well as the interactive dashboard can be found in the description below. And thus concludes my presentation. I hope you got what you were looking for today, whether it was to use my case study or me as a role model for your own Google Data Analytics project, or you were just trying to see how Ethan Chan handles a data problem. It would make me really happy knowing that I've helped somebody in some way. Thank you so much for your time, and have a good one.